Hello, good morning, or good afternoon, depending on where you are. Um, Thanks again for the parents who have supported Don's tutoring. My contact number is 980-320-5444 if you need to contact me relating to specific math tutoring. Today, we're going to be looking at trig graph application. This is one of the topics that a lot of parents or a lot of kids have expressed that they have a challenge with. As a result, we're going to try to address a specific problem right here to capture the key features of the sine and cosine graph and use it to actually apply to a specific problem. So let's get started. So the problem that we're going to be looking at here is as follows. A support post on a pier shows the height of the water as 5.4 feet at low tide, 2 a.m., and a height of 11.8 feet at the next tide high, 6.2 hours later. A. Write an equation describing the depth of the water at the location t hours after midnight. B. What will be the depth of the water at this support at 4 a.m.? So for the trig graph, there are some key things that we need to identify. We need to identify the midline, the amplitude, the period, and the frequency. To identify these things, the best thing to do is always to make a rough sketch, especially when you're given an application problem. So let's make a rough sketch of this problem. So the problem says that we are at 2 a.m. when the height is 5.4 feet at low tide. So we just need to make a graph. And with that graph, we're going to use t to represent the time and ht to represent the height. At 2 a.m., so if I start at my origin right there at 2 a.m., we recognize we're going to be 5.4 feet. So I can put that point in. They said at 6.2 hours later, so I recognize the distance from here to here, 6.2, and we're going to be at 11.8 feet. So going up 6.2 hours later, that's going to bring me to about 8.2 hours after midnight. And that's going to be there. Now, the beautiful thing about the cosine and the sine graph, it have a particular pattern, a cyclic pattern, which means each section of it is somewhat symmetric. And as a result, if the pattern starts at 2 a.m. going up to maximum height, we recognize it's going to come back down and the pattern going to start over again. So right here, this is going to be 6.2 hours as well. And that's going to bring me to, let me just erase this to make some space right here, going to bring me to 14.4 for the total time elapsed through one cycle. So with that, we can identify some key things. Let's go through one by one. The first one we're going to look at is my midline. And from algebra 1, if you remember, y1 plus y2 divided by 2, x1 plus x2 divided by 2, the same process right here. We're finding the midline of the vertical axis, which is the y-axis. So it's going to be 11.8 plus 5.4 divided by 2. And if we add those two divided by 2, we're going to be given 8.6. So we're going to calculate to get 8.6. So that's going to be my midline. Now, after I have my midline, I want to figure out my amplitude. And to figure out my amplitude pretty easily, I just need the distance from my midline to the top or the distance from the midline to the bottom. So the midline here is 8.6. Going from the top to 8.6, which is my midline, I'm going to get 3.2. So I can do it two ways. I can go from the midline to the top or the midline to the bottom. Either way, I'm going to get 3.2. So my amplitude, they're going to be 3.2. Now I need my period. And my period is actually the horizontal distance that represents the region for the graph, where the graph is going to actually repeat itself. So I recognize here from 2 to 14.4, the graph returned to its original position that we started right there. So obviously, if I should continue this graph out, the pattern will repeat itself. So My period then going to be equal to 14.4 minus 2. So that's going to give me 12.4. And that's going to represent my period. Now, I also know that the period, according to the formula that I know the period is 2 pi divided by b. So if 2 pi divided by equal to 12.4, I recognize that b here represents my frequency. So as a result, my frequency then would be, if I switch b with that, it's going to be 2 pi over 12.4, and this here would represent my frequency. Now, having all of these, we can actually run through quickly the graph that we're going to be using real fast. Now, we have two options here. We can use a trig graph of the sine function or the cosine function. Now, let's try to use the sine function first to try to solve this problem. Now, if I use the sine function, I recognize when drawing the trig graph, we must start from where the midline starts. So the midline is right here. Let me use a different color to make that pretty clear. The midline is right here. And starting from that midline, I realize the graph is going up. So if the graph is going up, this here would be representing my sine graph. And the reason why I know this is because I know that the generic or the parent function for the sine graph looks something like that. Parent's function for the cosine graph looks something starting from right here and looking something like that. So this is what the sine graph generally looks like, and this is what the cosine graph generally looks like. So I notice right here for my midline for the sine graph, the line is, the curve is intersecting the midline exactly on that point. So that is why it is a sine graph if I start from right here. So using that, I know right here where the midline is, this must be the midline as well, or the mid between the 2 points of 2 and 8.2. So if I want to find the mid distance between 2 and 8.2, I could do the same thing. 8.2 plus 2 divided by that, that's going to be 10.2 divided by 2. So this value right here is going to be 5.1. So writing my equation now using sine, this equation is going to be y equal to, I know the amplitude right here, starting from the midline to the top, is 3.2. I know it's going to be sine. My frequency, which I already established, going to be 2 pi over 12. I could simplify, but we can leave it like that if we may. And then I'm going to have x. Now notice now that's they're going to be a vertical, not a vertical, a horizontal translation of 5.1. So if I'm going to the right, it's going to be minus 5.1. And that's minus 5.1. And then I'm going to add my midline, which is going to be 8.6. So that completes the equation for the sine graph. Now, if I want to write the equation now for the cosine graph, using the same graph, so the equation now for the same graph using cosine, we recognize, looking at the parent function for the cosine graph, we realize we're starting above the midline. Here we're below the midline, so this is going to be negative 3.2. I put cosine. My frequency remained the same, so that's 2 pi divided by 12. And my translation going to be different now. Notice now, instead of starting at 5.1, I'm going to be starting at 2. So that's going to be x minus 2. And then my midline going to be 8.6. So I'm going to add 8.6. Now, I want to verify if these equations actually make sense, or if these equations actually work. To do that, I'm going to throw these equations into Desmos and see if they're modeling the same graph. So real quick, let's do that. So notice my equations are as follows. So I have y equals to 3.2 sine 2 pi over 12 x minus 5.1 plus 8.6. And I have y equal to negative 3.2 cos 2 pi over 12 x minus 2 plus 8.6. So let's check if what we're saying make any sense. And let's put both equations in, and we're going to verify. One of the nicest way to do this is to use Desmos, one of the awesome free calculator that is used to actually do a number of problems. Pretty awesome platform to work with, or software to work with. So y equal to, that's going to be negative 3.2. Cos, we need 2 pi. So what we're doing, we're going to press 2 and then we're going to use pi. That's how I get my pi. So 2 pi divided by, we have to be careful now. Notice I'm getting the parentheses there. So what I'm going to do is I'm going to put a parentheses around that. And that's going to be 2 divided by 12.4. Can put another parentheses inside. It's going to be x minus 2, close parentheses, go all the way out, close another parentheses, and then that's going to be plus 8.6. So this is my graph. So notice right here, that is my graph for the cosine function. Now let's try to work our magic and see if it works for the sine. We're going to put the same graph in using the sine function. So it's y equal to 3.2 sine 2 pi, pi to get my pi. Again, put my parentheses around that because we want to make sure that we're just working with what is for the angle right there. So that's going to be 2 pi divided by 12.4. Go back up, parentheses. That's going to be x minus 5.1. Good. Close parentheses, close parentheses. Then that's plus. Now we're going to check now to see if it actually works. On 3, we're going to do it. 1, 2, 3 plus 8.6. So as a result, we recognize it is the same graph. So using this map, so using the sine or cosine graph doesn't matter. It's just where we identify where is where for each. And that is it. That is my presentation on Trig graph. It's about 10 minutes. It's a quick overview of how to do the modeling. Now, before we kind of wrap it out, I just want to hit a last part of this problem. For the last part of this problem, we recognize we're trying to figure out how to solve. Okay, so the last part of this problem asks us what will be the depth of the water at this support at 4 a.m. where we have two options. We could plug it 4 a.m. into the actual equation, or what we could simply do is just figure out what is happening at 4 hours after by going back to our graph. So let me go back to our graph real quick. And we want what is happening at 4. So it's going to be, just put a vertical line of x equal to 4. That was 5. And that will tell us exactly the depth of the water. So it's approximately 6.907, or you could plug it in, you get the same answer in any of these equations. And that completes this section.